Stages of a data model. We have a conceptual stage, logical stage, and physical stage. And during the conceptual data model, we have we can have high level data models like ERD, key based data model, fully attributed, or a transformation model. These are the low level data models, or a DBMS specific model is a low level data model. ERD and the key based are high level data models. Logical data model which contains entities. There are a few types of entities: independent, dependent, existent dependent, identification dependent, associative or designative entity, and subtype entities. Relationships are like degree, cardinality, connectivity, and existence, which are there. Keys, like primary keys, foreign keys, concatenated keys, that is composite key, a candidate key, an alternate key, surrogate keys, and inversion entity attributes. So there are quite a few many keys which normally, I would say, more than primary and foreign keys. Relationship degree, that is the whether a relationship has is a binary or ternary in nature. Identifying non-identifying relationships and the role names. A relationship cardinality would be 1 to 0 1 or 1 to 0 1 or more, that is 1 to many. When we say 1 to many, it can be many, can be 0 1 or more than 1. 1 to 1 or more, 1 to 0 or 1 to exactly 4, or exactly n number of relationships, uh, or child instances which can be found, and 1 to only 1, that is 1 to 1 and only 1, which supports creativity. We'll see how it does that. Relationship and referential integrity actions like cascade, restrict, set null, set default, or none. 4 rules for modeling relationships. Subtype relationships. Subtype relations are a complete subtype and an incomplete subtype, an inclusive subtype or an exclusive subtype. Naming standards for entities, attributes, relationships. Physical data model. Again, we will be covering steps to convert a logical to physical data model, non-functional requirements, and how it influences physical data model. Physical data modeling standards and guidelines mapping between the physical and the logical data model, that is the data type mapping, and, and steps to convert a logical data model to a physical data model. Tuning strategies. These are proactive tuning strategies which you can use it to uh, model your database and make sure and be sure that uh, once the data model is into production, it does not end up into production issues or into performance issues right on the very first month of the project. Conceptual models, okay, but prior to that, let us see that the models are at various levels, that is the logical or physical model, which are having a detailed view of the data based on how data is retrieved, updated, and stored, or external models which defines the model from the end user perspective. These are the UML diagrams, state diagrams, activity diagrams, sequence diagram, interactive interaction diagrams. Conceptual model which covers the important concepts in its totality which are related to business and how these concepts are actually interrelated. And internal level models, that is the physical representations which take into account efficient processing of data. So a model consists of concepts, constructs, and operations. Constructs are representation of concepts. Operations are the processing or the interaction among the concepts or the processing which can be carried out over the constructs. So what a model must capture is the meaning of data, that is the data semantics, which help us in interpreting the data in its true intention. A data syntax or concepts or and data semantics are the two most important aspects of a data model, and it helps us uh, in capturing the real world context or the concepts. So a data semantics is captured through data types, interrelationship with other entities or attributes, and the data integrity constraints, the relationship integrity rules which are tied to that particular attribute or entity, the permitted values, uniqueness, existence dependency, restrictions on certain operations like insert, update, and deletions, and the data type length, precision, scale, nullability, format, cardinality, modality, range, default, uh, or all these things together forms a data semantic, which is uh, which is understanding the meaning of data through data types, interrelationships, and data integrity constraints. So a conceptual model. Before going to a conceptual model, let us see there are a few kinds of model which are created based on the scope and the level of detail they capture. Uh, Broadly, they are classified as area level and project level, okay, based on the detail. Uh, for example, an entity relationship diagram and a key based diagram are identified as area level diagram. So what is an area level diagram? It often covers a wide business area that is larger than the business which is chosen for to address. Okay, your problem domain or a model problem domain may be pertaining to a particular business, but when you see the area level model, or it can actually take the other applications which are also using the same model, or which are an extension of the model in or the process to which you are trying to model. So, while a project data model would be the portion of an overall data structure intended for support by a single automation process or an effort. That is, project data model would be focused to a particular process which you are trying to model. And the physical models are transformation model and the DBMS specific model. Again, you can see the entity relationship diagram will have a number of applications and their models encompassed into it. Similarly, a key-based model would have the would have will not only have those entities which are you have identified in the ER diagram, but also have their keys or the primary keys already designated to those entities. That is a one level detail or the first level detail, which is the most important detail for the entities and their relationship, will be defined in the key based model. However, a fully attribute model would be quite exhaustive and detailed, and it will not only have the entities, the primary keys, and the non-primary keys. It will also provide the alternate keys, inversion entries, and the other candidate keys which are there in that particular model. It will define data types not at a domain level but at actual physical level. Like it will not define a data type as a string, but it will define it as varchar2 of 30. A transformation model would be a model which is very close to the physical environment where the implementation is supposed to be happening. So it will have a lot of influence of the capability of the RDBMS where a particular model is would be generated. It is more physical database specific model, and hence it is a transformation model. However, a DBMS model again would be a larger model. It will not only have the model which is specific to your application, but it will also have the other models uh, which are which are covered by the entity relationship diagrams, which will rather it would be an integrated system of all the data of all the application models and their interrelationship between those applications. can be seen over here in the DBMS model. So as the level of detail increases, the scope will decrease, or as the scope decreases, the level of detail should decrease. Again, as the scope increases, the level of detail should decrease so as to have a proper comprehension of the project or of the overall business. And as the scope decreases, the level of details must increase so as to have a proper understanding or comprehension of the application model or of the model of the model of a particular process. So a conceptual model over here, uh, it is the same thing what I have actually said. So an ERD identifies major business entities and the relationship. A key-based model sets the scope of the business information requirement and begins to expose the detail. A key-based model is a data model that fully describes all the major data structures that support a wide business area. The goal of a key-based model is to include all entities and attributes that are of interest to the business. This is most important. The goal of a key-based model is to include all entities and attributes that are interest to the business. Choosing the primary key of an entity is the most important step in data modeling. I have already mentioned a couple of times that once a primary key is chosen for a particular data model, in all circumstances, a data modeler has to see that a primary key does not undergo change once the model is floated to the production. Hence, it is utmost important to use or to take assistance of the business user and his knowledge to identify a particular primary key, because it is the business who knows its data very well, much because he has a wider understanding of the or a detailed understanding of the business. So a modeler task would be to first identify all the candidate key attributes, and then with the help of business or with the help of a business analyst, he must then identify or designate a particular candidate key as a primary key in the key based model. In the lower level models would consist of a fully attributed model, which is represents a third normal form model which contains all the details for a particular implementation effort. It contains all the key values, key columns, attributes, and the non-key attributes, the relationships, cardinality, modality, everything defined and in place. Transformation model again is a database specific model, and it has even the data volumes, the volumetric information also gathered for it so as to do proactive tuning, creating indexes during the design phase of a data model. It provides a context for the definition and recording of the data elements and records that form the database in a data dictionary. And it helps the application team to choose a physical structure for the programs that will access the data as per their requirement of the project. DBMS model, a database design that is contained in the DBMS model for the system. Depending on the level of integration, now comes the disparate system into action. Here we are actually going to create an integrated model of the various disparate systems uh, which are around this, which with which your current model which you are trying to model has an upstream downstream relationship with. So model may be project level model or an area level model for the entire integrated system. Stages of a data model. There are three stages of a data model in a data modeling approach. Uh, uh, Conceptual model, which is created from SRS. So over here in this particular diagram, one can see what are the inputs and what are the outputs of a particular modeling exercise, except for conceptual model because it requires an SRS to be created, and it contains the conceptual model will contain all the major entities and their relationships. However, a logical model is created from the conceptual model, and it may be also called that a logical model is an extension of a conceptual model. It contains all the entities and attributes. So as a input to it, we can have the business process model and the data requirements, because it is the data requirements which will define the accessibility, the update, the deletion, update, insertion, what kind of activities that needs to be performed, and as an outcome of which we will have a logical data model which will have entities, attributes, relationships, and integrity rules all very well defined. From the logical data model, we will create a physical data model which will have technology specific inputs and the NFR document, that is the uh, performance considerations uh, which are defined in the contract to be realized using this particular physical data model, and the output would be tables, columns, keys, indexes, triggers, procedures, and other things. So at the end, we have business data, create an updation of the data by this particular business data by the various processes and stored inside the database. So in the physical model is highly influenced by the NFR document and by the technology which is used uh, for implementation of the database. So conceptual model, coming back to conceptual model, it is an ER model, and it is the most powerful. The ER model is the most powerful conceptual model. It is a precursor to a logical model, or can act as an alternative to a logical model. During modeling exercise, we hardly see anything called creation of a conceptual model, because conceptual model and logical model are considered to be uh, nearly the same. A conceptual model would be a logical model with less amount of information, or a logical model is actually considered to be an extension of the of the conceptual model. So uh, conceptual model merges the collective needs of all the applications to have a big picture. So this is how in the logical model the scope gets decreased and the detail gets increased. Determine conceptual model determines the various entities which are involved, identify the unique keys of these entities, and in the conceptual model uh, helps to freeze the scope of the database. Okay, it not only takes the pane area but also takes the models which are around that particular pane area into consideration, so as to understand and freeze the scope of database changes which are proposed by, or which could be proposed for relieving or for resolving a particular data problem or a business problem. So a conceptual schema or conceptual data model is a map of concepts and the relationships, and this it describes the semantics of an organization. Okay, it does not define the semantics of a data, but it describes the semantics of an organization, its processes, and represents a series of assertions about its nature. Semantics of data is given by the physical model or the logical model. In a conceptual data model, we can have the complex attributes, or the internal structure of complex attributes are not defined. We can have many to many relationships either resolved or otherwise. Even many to many relationships is fine in the conceptual model, and it can be tolerated. So associative entity may be present or may not be present. Associative entity is used to resolve the many to many relationships. Multi-valued attributes are marked away. Category attributes, that is for generalization, specialization, all these things are not done over here. Multi-valued dependency is like fourth normal form, which is definitely not there or not done in the conceptual model. Okay, derived attributes are also marked away. Conceptual model only focuses on the major concepts or the data concepts, and how they are to be captured and how those concepts are related to one another. They do not focus on how the concepts or how the data are stored. And this is what is modeling. Modeling finally at the end of the day, it decides how a data has to be stored within the database, how the integrity has to be brought into within the database. So the process of conceptual design is essentially to is essential to innovation, because it there is an abstraction layer or an abstraction process from the technology, and one can just focus on the business problem from a business point of view and not from a technology point of view, because as the technical complexities comes into action, the a person tries to think more from the real, more does not try, is drifted away from the business into the technical domain for realization of the problem. So uh, to to facilitate innovation for towards problem solving, it is necessary to have a conceptual design in place. It increases the visualization of the entire database structure and provides high level information of the various subject areas and the data structures of an organization. A conceptual data model actually starts with the discussion of the main subject area of an organization, and then it slowly covers major entities within each subject area which are related to one another, or through some kind of relationships. So the relationship between the subject area and the relationship between each entity in a subject area are drawn by symbolic notations. Logical data model. So this covers the conceptual data model, and hereafter we go into the logical data model, which sees that it is actually done to freeze the scope of the project. Conceptual data model actually aligns the main data model or the process model as well as the accompanying or the upstream and the downstream process models which are being impacted also together to understand or freeze the scope. But the freezing of actual freezing of scope happens only after understanding the problem area in the conceptual data model, and in the logical data model, where we say that okay, X, Y, and Z are the entities which will undergo a change, and this is the that, or X, Y, and Z processes are the only processes which needs to be modeled or which will undergo a change so as to realize this particular problem, uh, so as to realize the resolution of a particular problem. So X, Y, and Z are the only processes which will undergo a change. This is something which will be decided in the logical data model, and the logical data model will hereafter focus only on X, Y, and Z process models. So a logical data model represents the business requirements of an application and is developed before the physical data model, and it is primarily done to freeze the scope of the project. It is an implementation or an extension of the conceptual data model. Logical data model conforms to relational theory and contains fully normalized entities. It contains all the attributes, all the entities, all the relationships, all subtypes, supertypes, everything. Even the all it will have all the primary keys, foreign keys, concatenated keys, all will. Uh, so an ARD is made up of three main blocks, that is entities, attributes, relationships. That's fine. And over here we can also see the difference between the conceptual and the logical data model. So an entity is a principal object or a data object about which information is to be collected. Entity could be a noun phrase or a noun itself within a particular business statement. And it can be a person, place, thing, concept, or an event about which business has wills and means to collect information. Okay, it has to be a singular phrase, because it cannot be a plural one, like it cannot be named as customers, it has, or accounts. It has to be a customer. It cannot contain collective words like history or logs. Uh, it has to be a single instance of a collective name. So uh, it should not be an entity should not be an overlapping with other entities and should have a name acceptable to business. Rather, the name of an entity should be focused on the purpose of the entity and or the objective of the entity or the definition of the entity. So this is all about entity. Entity occurrence is nothing but instance occurrence within the entity, and it is analogous to a row in a relational table. Types of entities. An entity is a principal data object, and it is a noun on a statement, can be considered as an entity. So let us see how to go about it. Now, what are the types of entity? There are two types of entity: independent entity or a strong entity, which does not depend on any other entity for its identification. It is the parent table, which is a independent entity or a strong entity. A dependent entity is, in a relational terms, is a child table that depends on the foreign key attribute, that is the primary key, which is migrated from the parent entity for uniqueness and is also so a weak entity depends on the upon the value of the foreign key attribute for its uniqueness. Entities which are dependent or which are entities are in identifying relationship, the foreign key must be a part of the primary key. That is, a weak entity is a part of one to many relationship within the identifying entity on one side of the relationship and with total participation on the many side. This concept will be made clear over here. In the below figure, you can find out the team and the player. Okay, team ID is in one to many relationship with the player. Over here, team ID is used to identify a player ID, and hence team is a independent entity where player, okay, is a dependent entity or in identifying relationship with the team entity, because here the team ID is used as a part of the primary key to identify a particular player uniquely within the player entity. So weak entities may have partial keys and are related to other strong entities. In IDF1X notation, okay, dependent entities are represented as rounded corners, while in IE1, dependent entities are shown as square cornered boxes only. However, in the recent tools which we are using, always just for the compatibility between the various notations, that is in between IE and IDF1X, independent entities are represented as square cornered boxes and dependent entities are represented as round cornered boxes. Moreover, we can now see over here using this particular example that the primary key of the weak entity, that is this particular primary key, is the primary key of the strong entity plus the discriminating attribute or the partial key for of weak entity. So it is primary key of the weak entity, this two, player ID and team ID, is the primary key of the strong entity, that is the team ID over here, and the discriminating, here player ID is the discriminating attribute which is used for identification of in the weak entity. Now the types of dependent entity. So once a weak entity or dependent entity is identified, it can be further classified as dependent entity, that is existent dependent entity, or identification dependent entity. So what we have seen is an identification dependent entity where the team ID was used to classify a particular player, or team ID was used to identify a particular player. So hence it was called as identification dependent entity. However, existence dependent entity are those weak entities which will not where the existence of an instance in the weak entity depends upon certain instances to be present in the parent entity. For example, in an order and in this particular example of order and line item, there is no meaning of uh, tracking a line item without an order ID. So alternatively, if we have to look from the parent side, unless there is an order, there cannot be any line item which can exist without an order. So presence of an order determines presence of certain line items belonging to that order in the line item entity. So this is a existence dependent entity, which means dependent entity cannot exist unless its parent does exist. The other types of entities are characteristics entity. This is like this is more of a view like resolving multi-valued dependency or the fifth normal form, which states that a characteristic entity represents a group of attributes that occur multiple times for an entity and is not directly identified by any other entity. For example, hobby of a person may have multiple hobbies. Okay, so his hobbies can be taken in another entity and it can be thereafter related uh, to the original person to whom that particular hobbies belong to. So the the person entity will have only one instance, while hobby will have multiple instances which are belonging to the same person in the person entity. Associative or designative dependent entities. This is uh, quite interesting. Designative, we have many to many relationships which are actually resolved by the bridge table. So a person may have uh, uh, when the bridge table is used only for resolving the relationship, that is resolving the many to many relationship, it is called designative entity. And if the relationship or if the designative entity carries further information about the relationship, then it is called as associative entity. For example, over here the person and address, these are the two entities which are used to resolve, that is the address usage is an designative entity if it is used to resolve just the many to many relationship between a person and the address. That is, a person may have many addresses and one particular address may belong to many person. So to resolve that particular many to many relationship, we can have address usage as the bridge table. Now if address usage is only used to resolve this particular many to many relationship, then it is called as designative entity. However, if the address usage also has certain other attributes like type of accommodation, that is a particular person staying at a particular address will have a type of accommodation, let's say permanent, while the same person with staying at some other address may have a type of accommodation called rental or a PG, which would be like stating the characteristics of the relationship which is between the person and the address. So this would be designated as an associative entity. Now, subtype entities are dependent entities on the subtype using the subtype relationship, and they are discriminated driven relationships. For example, we can have a bank can have many types of accounts. So one is the account entity which would be generic, which will have generic information about the account. However, each However, each special account like savings account CASA account, check, loans account, all this will have attributes which are specific to the nature of that particular account. And over here we have achieved specialization using subtypes. So these are called as subtype entities or dependent entities, and in the entity, that is in the account entity, each of these entities or each of instance of each of these particular accounts will be the will be uh, uh, driven by a discriminator. Relationships. The more the relationships, the more the complexity it is. It represents the association among entities. It is the navigation path for moving from one entity to another. Relationships are very complex, and in the initial first look, they seem to be simpler, but they are very complex. So, a relationship represents connections, links, or association between entities. It also describes the rules of the business and the constraints on creating, modifying, or deleting instances. Relationships uh, are always present as verbs in a particular business statement or a business requirement statement. So reading the relationships back to the business architect, business analyst is the best way to validate the design of a logical data model. So always have a habit to read relationships loudly using the verbs to the business user. The relationship can be mentioned using the active verb, that is from the parent to the child, or the passive verb which is running from the child to the parent. For example, a flight transports zero or more passengers, that is from the parent to child, using an active verb phrase, while a passenger is transported by one flight, which is, uh, which is the direction of relationship from the child to parent using passive verb phrase. Relationship comprises of type, cardinality, and RI rule, or the relationship integrity rules. So type is the identifying, non-identifying type. Uh, So non-identifying types are further classified as nulls allowed or no nulls allowed, while cardinality is defines how many instances are involved in both the child and the parent entity for that particular relationship. RI integrity rules are achieved through using relationship integrity triggers and are used to restrict uh, insert, update, and delete actions when a particular relationship is defined between a parent and a child entity. So relationships are classified in terms of degree, cardinality, connectivity, direction type, and existence. So identifying and non-identifying relationships will again cover it over here. In the dependent entity, if the foreign key attribute from the independent entity is required to uniquely identify an instance in the dependent entity, then it is a identifying relationship. That is, from the in the child entity movie copy, when when a modeler requires the movie number from the strong entity movie to identify a particular row or instance in the movie copy, since the movie number and movie copy number are now together forms a composite primary key. So in that case, it is an identifying relationship. However, since the if the attribute is present as a non-key element, then it's a non-identifying relationship. Now, identifying relationship means child record cannot exist without a parent record. Non-identifying relationships are of two types. The non-identifying relationship is like if it is optional or mandatory. If it is optional, that means nulls are allowed for the attribute that are migrated into the non-key area of the child entity. If nulls are not allowed, it's a mandatory non-identifying relationship. Non-identifying relationship means that the child will not be identification dependent on the parent. However, by definition, some or all of the keys do not become part of the key of the child. Also, there can be situation where an entity at the many end, that is towards the child end of the relationship, can exist without a parent. That is, it is not existence dependent. This is evident by the diamond at the parent end. If the relationship is mandatory from the perspective of the child, then the child is existence dependent. If it is optional, the child is neither existence nor identification dependent, although it may be dependent in other relationships. To indicate the optional case, IDF1X includes a diamond at the parent end of the relationship, while IE includes a circle at as shown below. Over here, diamond, an empty diamond, and a circle over here, which states 0 or 1 passenger ID can be given 0 or 1 seat number. Identifying and non-identifying relationship is continued over here. In IDF1X, the type of relationship that connects two entities enforces the concept of dependent and independent entities. So, a dependent or an independent entity uh, over here in IDF1X is also mapped to identifying and non-identifying relationship in IE1. The migrated keys in the non-identifying relationship are not part of the primary key of the child. Non-identifying relationship does not result in an identification dependency. So in this case, it is the same what we have already discussed between the player and the team ID. Note, identifying and non-identifying relationships are not feature of IE methodology. However, this information is included in your diagram in the form of solid or dashed relationship line to ensure compatibility between IE and IDEF1X methods. So IE, in short, does not support identifying and non-identifying relationship in its true sense. However, this is the third-party vendor tools which actually does this particular compatibility, or which actually puts the compatibility between IE and IDF1X methods for ease or to reduce the confusion to data modelers. And in short, the stakeholders who are going to refer to this particular data model from the data model diagram. Role names in relationships. When a foreign key is contributed to a child entity through a relationship, you may need to write a new enhanced definition of the foreign key attributes that explains the usage or purpose of the child of the attribute in the child entity using a role name. Normally, when we migrate an attribute from the parent entity to the child entity, the attribute name is migrated as is from the parent entity towards the child entity. However, if you want to enhance the definition of the attribute in the child entity based on its role or purpose or objective or a change definition in the context of the child entity, one can use role names to redefine or rename that particular attribute in the child entity. Now, as and when this particular attribute from the child entity is propagated as foreign key anywhere else, uh, within the data model, it will be the role name which will actually be affected or which will be migrated into the other child entities wherever it will get referred to. Role names play a significant role when the same attribute is contributed to the same entity more than once. For example, in a trading where there is a buy price and a sell price, okay, the price itself is fine to it. But when it is a buy price, that means buy price is again a price, but it actually enhances the definition of the price. Similarly, sell price is again a price, but it enhances the purpose or the objective of that particular price column. So these duplicate attributes may appear to be identical, but because they serve two different purposes, they cannot have the same definition. In effect, a role name declares a new attribute whose name is intended to describe the business statement embodied by the relationship that contributes the foreign key. Once assigned, this is the same thing what we have already I have already told that once assigned to a foreign key, the role names migrates across a relationship just like any other foreign key. A role name is also used to model compatibility with legacy data model where the foreign key often had a different name from the primary key. Now IDF1X standard dictates that if two attributes with the same name migrate from the same base attribute to an entity, then attributes must be unified. That is, the result of unification is a single attribute migrated through two relationships.